Hello friends, today in this video I am going to discuss about the molecular structure in Fischer projection and chair conformation. So here we will discuss the molecular structure in Fischer projection and how to draw them and how to remember them easily. And then we will show how to convert the structure or molecular structure, any kind of molecular structure from Fischer projection to chair conformation and how we can draw them easily and remember them easily. So this is the main topic of this lecture. So for this topic we have chosen the glucose as the model molecular structure. So this is the structure of glucose, where glucose has 6 carbon. This is a 6 carbon molecule. So this is the carbon 1, carbon 2, carbon 3, carbon 4, carbon 5 and carbon 6. So glucose have 6 carbon, and here in the first carbon it has the CHO group, that is the aldehyde group, and in carbon 6 that is the CH2OH group is present, and in other carbon, that is the carbon 2, 3, 4 and carbon 5, here OH and H group are present or added here at different orientation. So based on their structure, how we can draw them in Fischer projection and how we can remember them. So for that, at first we have to know the basic or base of this structure in Fischer projection. So this is the base, that is a vertical line and 4 horizontal line like this. Okay, so in the top this is the first carbon, that is the CHO group, and in the lower side this is the sixth carbon, that is the CH2OH. Okay, and this OH and H group that are present here from the carbon 2 to carbon 5, they will attach here in different ways. So we have to remember them by the plus minus formula. So here for glucose the formula is plus minus plus plus. So how it confirm this? So for this, suppose in the carbon 2, here in the carbon 2 the OH group is present in the right side, so we will denote it as plus. So when the OH group is present in the right side, then we will denote it as plus sign. So when the OH group is present in the left side, we will denote it as the minus sign. Okay, so here from carbon 2 the OH is present in the right, so here we denote it as plus. Next in carbon 3 OH is present in left, so here we denote it as minus. Then in carbon 4 that is present in OH is present in right side, so it is plus, and in carbon 5 OH is present in right side, so it is also the plus sign. So the structure of glucose we have to remember, that is plus minus plus plus. So for Fischer projection, this is the model structure or base structure, and now we have to remember for glucose, that is plus minus plus plus. Okay, so plus means OH, minus means in left side, then plus means right side, and then again plus in right side. Okay, so this is the basic structure, and here we have to fill the hydrogen in the gap. Okay, so this is the basic structure of glucose in Fischer projection. Now we can we can make any type of conformation in Fischer projection of any carbohydrate structure by this formula, that is the plus minus formula, and this basic base structure. Okay, so and now to convert this Fischer projection to this chair conformation of glucose, at first we have to convert this Fischer projection structure of glucose to its ring form. So it is the open structure, so we have to convert it in the ring form. So to convert it to ring form, at first we have to go to the next, that is this structure. So this is also the glucose structure. So here in the carbon 5 OH group is attached. This OH group can attack the carbon 1, and then this oxygen or this OH group oxygen is attached or bind covalently to the carbon 1 and form a ring structure, and then this double bond which is present in the aldehyde group, this double bond is opened, and here this oxygen bind to the hydrogen which is released by this carbon 5 OH. Okay, so this structure will be seen like this. This is the carbon 5, and this OH group which is present in carbon 5 create a bond or covalently with the carbon 1 and produce a ring structure, and it produces a OH group and H group which is already present here. So now we can see this OH group and H group can be presented here like these structures. Okay, so suppose this OH can be present in the right side, or this H group in present in left side, that is one conformation, and in another conformation this OH can be present in the left side and this H can be present in the right side. So two type of conformation we can get from this ring structure of glucose. So here this is the two structure. So this one is the first carbon, here this one is also the first carbon, this one is the first carbon, this one is the first carbon. So here in first carbon OH group is present right side, here this OH is present in right side, so that will be called as alpha D glucose, and if the OH group is present in the left side then we will call it as beta glucose. So which conformation we will call the alpha and which conformation we will call the beta? So for that we have to remember two method. One method is simply beta means बाएं तरफ, इन हिंदी बीटा मीन्स बाएं तरफ, ऐसे अब याद रख सकते हैं, बीटा मीन्स बाएं तरफ. दिस इज द वे यू कैन रिमेंबर दिस, बीटा मीन्स बाएं तरफ. ओके, और in other way you can remember it as before and after rule. So for before means this one is before, so that is the beta, and after means alpha. This conformation is present in the after of this structure, and this is the present before this structure. So this is the before structure and this one is the after structure. So after, alpha denote after structure and beta denote before structure. Okay, before means left side, here it's come before, and this is after, it is come right. Okay, so in this way you can remember the structure of alpha D glucose and beta D glucose. Okay, और in other way beta means बाएं तरफ, ऐसे भी आप याद रख सकते हैं. ठीक है, so move on to the next, that is now this alpha D glucose and beta D glucose which are present in Fischer conformation of ring structure. So now we can convert this into the chair conformation. So this is the alpha glucose in their chair conformation and this is the beta glucose in chair conformation. So now we will see how we can draw this structure of glucose from Fischer projection to this chair conformation. So move on to the next slide. So here this is the ring form of glucose in Fischer projection, and this is the chair conformation of glucose in chair conformation. So this one is the first carbon, this one is the second, this one is the third, this one is the fourth, this one is the fifth, and this one is the sixth carbon. Okay, so why this chair conformation is known as chair? Why it is known as chair? So it is simply that because it is seen like a chair. Okay, so that's why it is known as chair conformation. So now move on to the structure, how we can convert this Fischer structure of glucose to chair conformation. Okay, so move on to the next slide. So here at first we have to draw this cyclohexane structure. This cyclohexane structure we have to draw. So how we can draw? So simply here this is a oxygen is present. So suppose we can draw it as, at first we have to draw oxygen or O ring group, and then I have to draw the cyclohexane structure like this, or otherwise you can draw the whole cyclohexane structure and then you can add the oxygen group. So this one is the better conformation I can suggest. Okay, so now so now we have to add this. Suppose look at this structure here, the perpendicular here you can see the H and OH group are represented by one straight line, one horizontal line. Okay, but here the OH and H group are represented here like in side line and a perpendicular line, a perpendicular line and a side line, a side line and a perpendicular line, in this way. So at first we have to know how to draw this perpendicular line. So this perpendicular line we have to draw at first. This one is the carbon 1. So this one is the carbon 1. So for this we have to draw the perpendicular line in the downwards like this. And in next, all the perpendicular lines have to draw in opposite orientation, means alternatively. So here in carbon 1 the perpendicular line is downwards, in carbon 2 perpendicular line will be draw upside, in carbon 3 perpendicular line will be downside, and carbon 4 perpendicular line will be upside, and in carbon 5 the perpendicular line will be downside. Okay, so in this way alternatively, in carbon 1 downside, then upside, then downside, then upside, then downwards. Okay, so in this way perpendicular line we can draw. And next, that is, and this structure, these perpendicular lines are, the structures are known as axial position. Okay, and the side lines, these lines are known as equatorial position. So equatorial position we have to draw by, at first suppose this is the carbon 1. So this is the carbon 1. So the opposite straight line of this carbon 1 is this. So we have to draw a parallel line opposite to this line, opposite to this straight line. So this straight line is go in this way. So we have to draw the parallel line like this way. For 2, the opposite straight line is this one. It go this way. So we have to draw parallelly in the opposite direction. In carbon 3, so here the opposite one is the this one. So it go this way downwards. So we go it upwards in opposite direction, but parallelly. In fourth carbon, the opposite one is this one, go upside, so it will go downside parallelly. Okay, in carbon fifth, this one is the opposite one, so it go this way, so we have to draw it this direction parallelly but opposite way. Okay, so in this way equatorial and axial positions are drawn. Okay, and now we have to draw how the OH groups how these OH groups and H groups are placed here. So here this structure, this Fischer projection is for alpha structure. Why? Because here the here the OH group is present in after. If it is present here, it will be called the before. So here the OH group is present in after, that means in right side, so it is alpha structure. Okay, so now to draw this structure we have to imagine a man head this towards its head to this the first carbon. So its head towards the first carbon and its hand extended to this way. So its right hand is same to the this structure, that is present, the OH group is present in right. So its left hand is represented here as a left of this structure. So it is same as the structure. So here in this structure OH group is right and his right hand is there. So his right and the structure's right is same. Okay, so now we have to place this man to this structure like this, and his heads will be follow the carbon 1. Okay, and this will be his right hand and this will be his left hand. So right hand is downwards, left hand is upwards. Okay, so all the OH groups which are present in right side, then they will go to the downside. Okay, so like here, this is the structure. So for alpha, OH group is present in right. Okay, so right means downside, so we have to place the carbon 1 OH to the downside like this. And next, for this is the carbon 1. For carbon 2, the OH group, we know that for from carbon 2, the conformation of glucose is plus minus plus plus. Okay, so for plus, that means OH group is right, in right position. So for right position, that is present in the downwards, so OH will be present in downside. And for carbon 3, that is plus minus. For minus means left side, so left side means upward. Okay, so it will be present in upside. Okay, and in next, this is the carbon 3. So for carbon 4, that is a plus minus plus plus, plus minus plus, so this one will be plus. Plus means right side, right means downwards, so in this way. Okay, and last one, in the last, the CH2OH group will be placed like this. In every time, CH2OH group will be placed upside. Okay, and the other things will be completed by hydrogen, gaps will be completed by hydrogen like this. Okay, and this one, there no position is open because there is oxygen is present, the O ring structure is present. Okay, so this is the structure of glucose. So now if we gist this all structural conformation, where we can see what we can see. So this is the Fischer projection ring structure. So at first we have to draw the cyclohexane structure, then we have to draw the axial and equatorial position. Axials mean perpendicular, so perpendicular, the first here, then downside, then upside, then downside, then upside, then downside, then upside. So in this way we have to draw. And in next, basically here the oxygen is present, so no axial or equatorial is present. Okay, so this is the conformation, and then we have to draw the equatorial. So this direction, this is the opposite, so we have to draw it like this. And for second carbon, this is the opposite, so I have to draw like this. So in the third carbon, for this one is the opposite, so I have to draw like this. So for this one is the opposite, so I have to draw like this. And for this one is the opposite, so I have to draw like this, parallelly but in opposite way. Okay, so this is the position, and then we have to place the OH group and hydrogen group as per the, as they are present, like their head is towards the carbon 1, and this is the left hand, this is the right. So this, all the OH group which are present in right side, they will be placed in the downwards, and all the molecules or H or OH group present in the left side, they will be placed in the upside. Okay, so in this way we can make the conformation of glucose or any kind of carbohydrate structure from Fischer to, for Fischer projection to chair conformation. So if anybody told you to make a structure or draw a structure of chair conformation of glucose without giving the structure of Fischer conformation, how we can draw? So we can draw, just make a oxygen ring like this and produce the cyclohexane structure. This is horrible. Okay, and next we have to draw this perpendicular structure in opposite direction. Okay, and in next we have to draw the equatorial position like this. Next, this one is this direction, so we have to draw this direction. Next, this direction, so we have to draw this direction. So for this have this direction, so I have to draw this direction. So this one is for this direction, so I have to draw this direction. Okay, and now we have to place the oxygen. So if they say the beta glucose, then beta means बाएं तरफ or beta means before means left side, so left means upwards, so upwards means here we will place OH, and then plus minus plus plus we have to draw it here, place it here, like there, here the present weight and age groups. So in this way we can draw the chair conformation of any kind of molecules of carbohydrate. Okay, and we can also convert them from Fischer projection to chair conformation. Okay, so this is all about this lecture. Okay, so thank you for watching this video.